All right, well, now we can go with the regularly scheduled program. Hello, everyone. My name is John Rodriguez. I work at Square on the Cash App product. How many people are familiar with Cash App? Okay, great. We are available in the UK, but predominantly based in the US in terms of an app product. So to see people familiar with the brand, I hope will be a matter of our open source development, which I'll talk about. So today I'm going to be talking about a testing library called Paparazzi that I've been working on for the last 2 years on and off and trying to ship a 1.0. And so if you're not a user of Cash App, it's helpful to know that Square Register, the point of sale, the thing that people are most familiar with the Square company, they work on the business side helping merchants take payments. I think in Berlin, there was what was the name of that app that we used in Berlin to settle tabs? It was like the NFC, whatever. There are equivalents in Europe for the point of sale. Cash App is more on the consumer side. It's like the Venmo, the PayPal, how you do money transfer. And so we're enabling short-term loans and managing money through banking, buy Bitcoin, buy stocks, et cetera. But similar to our parent company, Square, who you've probably used some of the libraries for, OKHDP, Retrofit, Leak Canary, Picasso maybe. The Cash App team also has a commitment to open source. And so you'll see that we have a new GitHub domain. We're still in the same parent company, same family, but from a branding perspective, we're starting to move some of the open source projects that we create over there. Part of the reason for this is that on the Cash Android team, we move very fast, and we want our tools to be able to do so. When I joined the team, this was around the time when Jake Wharton had left Square to join Google. And so I joined a small team that, with much success, has grown to be much bigger. And keeping product velocity and delivery up to those same expectations as you may have encountered on your own teams proves to be challenging. More people in the code base, different product verticals and directions, and of course CI builds and all the things that come up with the day-to-day job. Eventually, Jake came back, and so we're happy to have him because obviously he has all the insights and of his experience to contribute. Okay, so the premise of this is our design team on Cash App also iterates fast. They have huge vision. We're constantly, every year or two, rewriting the design look of the app, and if you work in companies that do similar, that can be somewhat challenging as well. And sometimes engineering priorities and design priorities don't always align. And one of the things that we sought to seek is why can't it? Why can't we have a tool that keeps up with that? How many times have you had a new feature where you customize a widget and now you broke that widget everywhere else in the app? You may not think it's a big deal, but your designer will. They're really caring about the user experience and how everything looks to be pixel perfect. And so that's what we're trying to satisfy here. There are engineering benefits as well, which I'm going to get into. But starting off here, see if you have your Figma screen right here. How many people use Figma for their design iterations? Great, cool, really great tool. We love it. And we've been collabing with them on how to build plugins to make our tooling even better. And so if you get something like this from your designer, like we're releasing a new cache card, and you're figuring out how you're trying to design this view, there might be some animations, some SVG lookups, all that. You might start off here in an XML layout, which, that's like old school. No one does it anymore. But when I originally wrote this talk 2 years ago, this slide stuck. So, but you might start off here. And from here, you go into Layout Preview in Android Studio to take a quick look how development is going. And this is nice for pretty basic views. But, for more complicated views, or if, dare I say, you have business logic in your views, you might get something like this, right? How many people have seen more like this in their Layout Previews? Yeah, we all have, right? It's frustrating, but there's reasons, which hopefully you'll understand at the end of this talk, why that might be. But the point is because of that limitation, what you probably then have to do is, in order to view the screen, you have to build the app, you have to install it on a device or an emulator, and now that means you have to run Gradle. And I kid, I love Gradle, but at the end of the day, if you want to just test a view, it does feel like it's a bit overhead to build the entire app, deploy it via ADB to an emulator or your device, which is more likely because that's faster, who has all the RAM in the world to support Android emulators. But seriously, the point is the Android build toolchain is very complex. Just to get to the goal of viewing a screen, you have to crunch assets, resources, transitive library manifests have to be merged. They have to be linked through the apt daemon of the Android Gradle plugin and ultimately packaged into a APK. You have to, of course, compile the source files, put them into class files, desugar, shrink them by R8, If you're using support libraries, you have the Jetifier transform. It's like, why do all this? And then finally, you package it onto the emulator. Maybe instant run works, maybe it doesn't, who knows. And so build times add up, right? Again, all you're trying to do is to see whether your theming or your view renders correctly. You have other problems to solve with dependency injection or architecture. None of these should come up in looking how a view renders. And so here's what happens ultimately. We just signed up for Gradle Enterprise. If you saw the talk I gave yesterday with Ruse from Gradle, we love it and it solves certain problems. But it's still slow, even with the optimizations. Well, this is a little old, actually. We get incremental builds closer to 2 minutes, but let's say 4 minutes. Let's say this is, you see 4 minutes is like, wow, I wish my app built in 4 minutes. And our team is filled with a lot of Gradle savants. Like, we know when the experimental flags come out. We know we're on top of this, and even so, we're still limited by many things in the tool chain. So we're going to skip that because that's what I said in Berlin, and that talk has already happened. But once this is finally done, you're on your device in emulator. Now you have to find the screen. It's not necessarily your launch screen, right? So maybe your app flow is server-driven. Maybe it's behind a feature flag. Maybe staging is down, and so even though you got this far, in order to get to that screen, you had to make a network request, and staging's down, boo-hoo. So there's so many obstacles, and this is not unique to the cache team, right? Android developers all over the world, such as you all, have faced this burden. So back in March of 2019, during a Hack Week project, Jesse Wilson and I, Jesse Wilson being author of cool libraries like OKHDP, we started digging around in the Android sources and seeing how Layout Preview in Android Studio works itself. And so after digging around, we found out that there is something called a layout lib jar that's loaded by Android Studio that is primarily responsible for the layout inspector. And so in pure hacking spirit, we took some of those core bits out, tried to figure out the API either just by using Java P or hopefully some of the sources on the Android repository, and borrowed some ideas from the Android Gradle plugin how we can run the true rendering pipeline of Android on a JVM instead of building it for the device or emulator. And in our initial proof of concept, instead of the usual build times like I showed you earlier in terms of minutes, JVM tests take a matter of seconds. Of course, your mileage may vary, and we'll get into that. Now, instead of running all these bits of the Android toolchain, we only have to run the bits that are necessary for JVM. We no longer have to dex files. You only have to get them into class format because it's running on a JVM. You don't have to do a lot of the resource crunching, and I'll explain why in a second. You only need to reduce to the bits that are necessary to compile your layout resources, essentially r.jar, and then populating your UI with view model data, which is simply JVM class compilation, source file compilation. So in early 2008, we released this as Paparazzi. That's the code name we used. And the premise was it's 100% written in Kotlin, and it's meant to accelerate Android UI development. If this is your first time seeing Paparazzi, this is how a simple test would look. It's a JUnit rule, so you instantiate it as so. We're using sensible defaults. I'll go into some of the ways you can customize this later. You either inflate your view or instantiate it directly if you're using something like Contour, or we'll talk more about Compose later. But on the Cache App team, we released a library called Contour, which allowed us to do essentially coding our views with lambdas to get around some of the API constraints, limitations of constraint layout. We're not fans of constraint layout because while it sounds great in premise, when you bump a version of constraint layout and your view breaks, it was frustrating us. And so we decided to simply do the math behind rendering the views accordingly, and we like it. And so this is how our tests tend to look more now. We instantiate the view directly. You'll notice that we pass the Paparazzi context, and I'll go into why you would go to Paparazzi for that context in a bit. And then finally, you call Snapshot on the view that you've instantiated. So there are 3 modes that Paparazzi runs in. The first one is test. And test debug here because Android variants. You could have a test release. You could have whatever product flavor you want. But the idea is that this view will give you your iteration cycle. Now when you want to develop a view and you want to see how it's going, you would either run the play button or just invoke it on the command line using test debug. At the moment, we spit a pretty primitive web page with some scrollability. I'll talk a little more about how we're going to improve that later. Once you're done iterating, you probably then want to take that snapshot and commit it to source control as the golden value for your future tests. And to do so, you now invoke record. And you'll see the thing to note is that now it'll deposit that snapshot in a predefined directory, again, customizable, but we chose to put it in source test snapshot images. We do have future support for video for animations, so it'd be under snapshot videos. And this allows you to check for like missing frames, dropped frames, etc. And then on CI, or in your manual tests, on your day-to-day development, you will run a verify task, which will compare that previously saved golden value to whatever the current state of your source rendering would be. And this is where you'll catch those regressions. If you make a change, you apply a new theme, and oops, you broke the rendering, you should see it fail the test, and it'll give you a delta of what the expected and actual values are, just like you would expect of any JUnit library, showing you where you went wrong. And hopefully, it'll help you figure out what to do in order to fix it. How many people are familiar with test parameter injector library? Great. How many people were familiar with square burst? Cool. So both libraries, the TLDR is square burst is deprecated, and you should move on to test parameter injector. So Square came out with this library called burst that allowed us to iterate over all the permutations a unit test may take. So if you want a unit test to test all soda brands and your enum is Pepsi, Coke, what have you, you can run your test, instead of writing the test 3 times with just a one-line change, you would parameterize it with this enum of soda, and it will do the iterations for you, passing it all the values. If you're not using it, it's very handy. But Google released test parameter injector that allowed for even more flexibility, and we're huge fans of it. So that's kind of just a promotion of the tool. If you're not using it, check it out. It can help you write better tests. Screen will look on different device configurations and on different themes. And so we would define the enum values there. Config has 2 values. Theme would have 2 values. And so the cross product of those enum values would result in 4 instances of how this test might look. And then we do similar to what I showed you before, configure the test to invoke the rule. You'll notice now that we supply those 2 enum, basically the iterative step of each of those enum values are now passed at various points, either at the beginning of the rule or in the test iteration. And now we get an array of screenshot tests that can show us. And so the action bar theme is where you see that white gap in the top and different landscapes. A little bit about our architecture, since you don't necessarily see the Cash App code base, is similar to probably all of you. We want to keep our business logic and our view logic separate. We went through iterations where we're really huge on RX Java and trying to get observable transforms and views interacting with each other. We had some short-term architecture decisions that now we're trying to peel away from. We have an internal framework that is codenamed Broadway. It hopefully will be open source soon. That makes this contract between presenter and UI more explicit. But just on a high level, without going into details, the contract of a presenter is that it emits UI events, either through clicks, scrolls, or any other way that a user would interact. It accepts those and spits out view models. And sometimes those view models are side effects. Like you don't need to render a view model if you're either logging to analytics or navigating to another screen. On the flip side, the UI, your view, your backing view, will take in that view model and handle the events based on the interactions with said view. So just with that contract alone, Paparazzi tests become a lot simpler for us because now it forces, even if we committed the sin of putting business logic in our views, these contracts now prevent that somewhat. And so the UI interface that we defined just has a set model method, and we pass our view model, do all the things you would expect it to, set getters with metadata, and now our view, that's the backing test, just now pass a model. And so now we add in a single line where we're not just instantiating the view and taking a snapshot, we can run through several permutations of models, checking for nullability, checking for render states, maybe you're hiding subsections of your view depending on the nullability of a field. By just a simple contract, you can test all those states and your designers will be happy. It also helps simplify client-server interactions where either your missing JSON field or nullable protobuf field will come over from server and you can test all the variations your view may render based on that contract. Internally, we have a Snapshot browser that we're also hoping to open source on Paparazzi, and this is helpful because now we can compare screenshots on iOS and Android, and our designers can see how adherent we are to their standards. And so based on this array of screenshots, this is a view where if you order a cash card, this is actually running an OpenGL pipeline for the 3D card, and there's so many things that we can do with shadowing and customizing the card. And so this is a nice test case to really see where Paparazzi's limitations might be. Because OpenGL itself has complicated stuff with native code and matrix transformations, but still we want to keep that bar, and we want to see whether our tests regress, regardless if they're simple text views or if they're doing more advanced things. And so the Snapshot browser here will show a lot of we have about hundreds, if not we're reaching 1,000 screenshot tests on CI that build on every pull request. So now that's the high level. Let's dig in a little more. Let's peek behind the curtain and see how Paparazzi works under the covers. So I already mentioned there's a JUnit rule, and Paparazzi leverages that. And it's a bridge between this thing called layoutlib, which will be the focus of the talk as well. Underneath layoutlib is the Android framework, the view.java is all the things that you know about Android. And then there's some delegate classes, which we'll also talk about in a bit. Let's start with layoutlib. So if you've been doing Android for a while, Layout Preview has been around since API 5, back when Eclipse was the IDE, when there was the Android developer toolchain, and you might have been programming or building your app with Maven. Even though we're using IntelliJ through Android Studio and Gradle, Layout Inspector is still present and used by many. And so the question is, how does this work? For example, if you dug around the Android framework sources, you know there are native calls. You know that you're doing hardware interactions. How does that work in the IDE? So the entry point of layoutlib, the thing that powers Layout Inspector, is this thing called a bridge. And we're not going to go too much into that because I'll spare you that. But the thing to note, actually, there are two methods that are important. You init the bridge, and then you get something called a render session. The render session is your handle to providing this, essentially a buffered image. An image, your snapshot, is handled by the that render session object. So the bridge will set up the world through init, and then finally you get a session, and via that is how you get the snapshot. And so digging into the init method more, again, messy code, but the bit that I want to point out is, oh, look, there's something called a bridge context that acts as a context. There's a bridge inflator, which will do layout inflation. And underneath that, there's a pull parser. And you may notice that this is an XML block parser, which is kind of interesting because if you've done Android development, you see that it's usually a binary XML parser. If you unzip your APK and you're familiar with how resources are packaged, you'll see that layout resources packaged in your APK are, there we go. Look something like this. They're not text-based, they're binary-based. And this is because APKs want to be as small as possible. They want to parse more efficiently. Launch speeds are a consideration, especially if you have complicated layouts. And none of these considerations, so other thing to point out is, but if you introspect it, you will see some of the familiar XML attributes present. In layoutlib, because we're not looking at the APK, we can just look directly at the file system. So we don't need a binary XML parser. Instead, we need a text-based XML parser. And so that's one of the things that layoutlib essentially fakes out of the Android platform. It fakes out the ability to do layout inflation by using a text parser. Also note that layout inflation and layout resource crunching is something that's handled by AAPT. And as I said earlier, we're not running that anymore as part of this. We're trying to sidestep all that. And so something has to kind of bridge that gap. So now that you have a high-level understanding of layoutlib, it basically assembles things that you are familiar with from Android. We do need to go a level deeper. We still have those native calls. And so that's where the delegate classes come in. If you look inside the repo of layoutlib, it's open sourced, you see that there's a create folder. And so well, let's take a look at basically how these delegates work and how layoutlib create works. Layoutlib create, I should say, is a bytecode transformation tool. The Android framework is packaged into android.jar. Android.jar will make calls to either Java code or make calls to native code. Layoutlib create has a DSL, and that DSL is essentially going to do bytecode transformation and say, anytime I see a native call, I'm going to replace that with something else. And so if we look at resources, right, we see, oh, I missed a step there. Let's go back. This is how resources get drawable would look if you look at the Android open source project. What layoutlib will do, or layoutlib create, it will replace that method and with an original suffix. So getDrawable becomes getDrawable original. And then there'll be an annotated method called layoutlib delegate, which replaces the call site. So now when you call a method, instead of going to the thing on device, you're instead going to a bytecode intercepted method. That's important because this is where the magic comes in. If you're familiar with how roboelectric shadowing happens or how Mockito does mocks and spies, it's the same idea. It's using bytecode transformation to intercept your calls on the call stack and route them to something. The reason why layoutlib does this is, again, we're not going to have the native platform underneath. We need to route it to somewhere. So instead of drawing to the OpenGL canvas, you're going to draw to Java AWT buffered image. And then these delegate classes will essentially rewrite the portion of the Android framework, but in a way that makes sense for the IDE. So for resources, instead of looking up the resource map and pointing to a binary version of the resource, it's going to look in your file system for the XML text file that represents it. And so layoutlib makes heavy use of these delegate classes. If you take a look, you'll see that it has a delegate for pretty much everything that you would think. Typed array. If you know how resource IDs are looked up, you'll know that it also involves some native calls. Bitmap factory. Anything with calendar or date APIs also have to be mocked out. Now, I did say that Android makes a heavy use of this, or rather layoutlib makes heavy use of this. That recently changed. One of the glaring problems was having to do with fonts. So the way that fonts were being handled originally is you would rely on the JDK's font metrics, things like ascenders and leading and all the things that make every single pixel or how a font renders possible had to be replaced by the JDK. It turns out that JDK implementations differ by the platform. So you may run the font metrics on the Linux JDK, and on Mac OS, you get a slightly different rendering. And so the pain points of the layoutlib team at Google was essentially every version of the IDE, they'd try to fix a few bugs to make font rendering a little bit better. And it turns out that was an impossible task to chase. And someone had a great idea. They said, well, why are we replacing the Android framework? Why don't we just run the Android framework itself? And so as of Android Studio 4.2, you may have seen that there was a rewrite of the layout inspector called the native layout inspector. My earlier claim about the OpenGL pipeline not being ran is no longer true. Now you are running the Skia rendering pipeline that runs on an actual device, but in the IDE. They load the entire Android runtime through JNI bindings as part of the IDE presence. That may have an effect on why Android Studio is a lot heavier on your computer. I'm actually not sure about that. It might be a combination of that and Gradle. But I wouldn't be surprised if you're loading the entire Android runtime. And so why does this matter? Let's look at a meaningful example. Who can tell the difference between these two views? I was going to say, can you? You got some good eyes. All right, let me help you out. How about now? And so your designer cares about this stuff. While the rendering pipeline of fonts before taking into account things like letter spacing, the letter spacing calculation for a certain font is handled in native code. If you're using balanced text views, the calculation of line breaks based on what determines balancing is also native calls. And so every time there was a native call on Android, the Google layoutlib team had to rewrite it in JVM code. And there's a lot of these calls. So they just abandoned that and decided, let's just use the framework, and you get better pixel perfect rendering as a result. I think it was a great decision. And I hope you think so too. OK, so now that we understand how delegates kind of work and layoutlib works, let's go back up the stack and talk about how you would interact with Paparazzi. So as I mentioned before, Paparazzi aims to be configurable to however you wish to test your app. But at the same time, we try to give reasonable defaults. If we focus on the Snapshot handler, for example, we see that depending on what mode, or you recall I mentioned 3 modes earlier, test, record, or verify. If you're verifying, then you just need to do a snapshot verification. But otherwise, you can generate that HTML report. There's also an environment configuration. And so this is to try to understand how to bootstrap Paparazzi. Paparazzi has to know where things like resources and assets and where your Android platform lives. And so this is essentially the constructor for Paparazzi. If you follow the conventions of setting your Android home and your JDK, Java home rather, Paparazzi rewards you by just figuring this out already for you. If you're familiar with RoboElectric, back in the day you had to provide a properties file that kind of pointed to these things for you. Paparazzi takes it a step further and realizes that it can infer a lot of these things and avoids you having to customize it yourself. And the way that it does that is leaning heavily on Gradle. And so if you look at the Gradle portion of Paparazzi, you'll see that there's one task that needs to be run, this prepare Paparazzi resources. Because it's an Android test tool, it can make the assumption that the Android Gradle plugin must be applied in order to work. As a result, it can rely on that you're compiling some JVM sources and that you're going to have to merge resources, because those are things that are present in every Android build. And so it wires itself to be in between those two tasks. Similar things happen for assets and for Java compilation, because you're probably using Java if you're using Dagger, unfortunately. And so let's focus on the merge part. One of the outputs of the merge resource task is all the transitive dependencies, the support libraries, the graphics libraries that provide a resource, those all get merged and deposited in this folder. I mean, didn't you know where this lived? The Gradle plugin gives that information, and then Paparazzi writes it to that text file we saw earlier, along with some other metadata. And then it's finished. It wrote the file. That's all it had to do. Later on, when you're running the test, because that's where the JUnit rule is running, Paparazzi goes, I expect a file there. Ah, there it is. Now, we don't hard code it. We supply it as a system property. And you'll notice that we use this pattern for a bunch of things. For example, it turns out that the test task to run Paparazzi in test mode, record mode, or verify are very, very similar, like 90% similar. The really thing that matters is what is the form of the output. And so rather than copying the code 3 times, we try to minimize that, and the initialization of that test task is controlled by another system property. What this means is now instead of depending on the Paparazzi JUnit artifact directly, like this, you'll do something that's more like plugin, like add it to your build script, or if you use the new plugins API, you can use that. And then applying the plugin to your test project. If you checked out the LayoutLib project on the Google open source repository, you'll see something like this. As of Android Studio 4.2, as I mentioned, they've moved to native runtime libraries. This posed actually a little bit of a problem from a tool chain. So this is a bit of a segue, or rather a side note, I should say. It's helpful if you ever have to encounter something like this in your day-to-day. The runtime has native libraries, and so it has to have these operating specific versions of the runtime. It has to have one for the 3 popular libraries, platforms that you'll probably be using, as well as a JVM bootstrapper, which is LayoutLib native JDK 11. At runtime, one of these platforms will be detected and loaded. But if you know how Gradle works, Gradle uses dependency caching. That works well for JVM dependencies. But if you look at how LayoutLib works under the covers, my animations are off today. If you look at each of those native libraries and remember how the bridge method worked with the init class, you have to supply file paths. And so Gradle doesn't work well like this out of the box, where usually you get a jar and you class load it, and then you expect the class to be available via the IDE. Supplying paths aren't necessarily a thing you can do easily. But one of the nice features of Gradle is something called artifact transforms. And so not only can you cache dependencies, you can run it through a process that transforms the dependency into the flat file system. And now instead of every Paparazzi project having to unzip the jar and supplying those file paths, which would be costly, you'd have your temp folder filled with all these unzipped jars. Gradle knows now to go directly to the file system for these libraries. And so essentially your performance is optimized. You download it once for whichever project uses Paparazzi, and you don't have to download it or unzip it again, and you have paths to the file system to what Paparazzi needs to bootstrap. So given that we have first-class Gradle support, a natural question is, will you have Bazel support? On Cash App, we don't use Bazel, but we know it's a popular ask by the community. And so we're hoping that the community will help us provide a solution to that. That being said, that explains heavily why we relied on system properties. And so really, Paparazzi doesn't care if you use Gradle or not, as long as it has the proper system properties in place and that resources file generated where it expects it, it can run as expected. This was a suggestion made by some Spotify engineers during the early development of Paparazzi, and it turns out to be a really good call from an API design. What we need now is to have the Bazel plugin that someone provides do some of that work in duplicate. So if you're familiar with Bazel and you want to use Paparazzi, we will accept PRs. We're looking for it, but we wouldn't maintain it ourselves. Let's talk a little bit about accessibility. In the past year, we've been really trying to double down on being more accessibility friendly. We've always wanted to. Our customers expect it of us. But priorities are priorities, and sometimes some slip through the cracks. And so we thought, can we use this to maybe help us not do that and include this in our sprint planning a lot better? So what we use Paparazzi for, again, using that same test parameter injector library, we introduced a concept of we started with font scaling. Let's see how this looks. And so with some utility methods where we scale the font based on that enum value, and along with this scrolling snapshot method, we have this function here where we scroll manually through the scroll view or recycler view, and snapshoot, I guess the present tense, snapshoot the view at various stages in its scrollability. And so, for example, we have this view in the banking portion of Cash App where we show both the original and scaled fonts. And so this is helpful to know that if, for example, you need scaled font size and accessibility, does it still look to spec? As you probably imagine, sometimes your margins are off or sometimes text is cut off, and our designers don't like that either. So we want to make sure that we're really configuring our views appropriately. We took it a step further recently. A teammate of ours, Jeff, decided, what if we extend Paparazzi where we know that Paparazzi renders an image at the end of the day? What do we provide mechanisms to render additional data on the image, essentially overlay images? And so while the original purpose of this was for accessibility, we decided, well, that's what we know, but the community might have even more ideas of how they can use this to their advantage. So we generified it into something called a render extension, where you take in the snapshot, you get in the view information, you get the image, and then hopefully you extend it in a way that will overlay images onto that. And so in Paparazzi internals, when you take a snapshot, that bridge render session image, that's what the render session gives you at the end. That's the handle to that bitmap. We pass it through some scaling, and then eventually give it to a frame handler. That frame handler is either the thing that verifies the snapshot or the thing that generates the report. It just handles a frame. So what we decided is we can wrap that further. We can run it through a sort of like an interceptor pipeline where we take that image and modify it in some way. And so, as I mentioned, the use case for this was accessibility. So Jeff landed this PR. If you're familiar with the iOS side of things, tell your iOS developer we already have an open source project for this where it takes accessibility snapshots for iOS. Really handy. We lean on this very much. And Nick Enton, my teammate, was the author behind this one. And so we decided to mimic it. And this is what an example looks like. It's now we still take the snapshot of the view, but we also do an accessibility walk through the view hierarchy, or rather the accessibility hierarchy, to see which accessibility nodes aren't compliant and render it as in this case, we do some overlaying, but also an additional pane to make it a legend, if you will, to show what parts are missing. A little primitive, but we hope to extend this more in the near future. So we take the original Paparazzi test to enable this. It's a one-line add. We just add the accessibility render extension, and now you get all that feature set out of the box. One of the interesting parts of trying to use a portion of Google's repo is that their bugs become your bugs. And so, for example, when bumping from layout lib 4.1 to 4.2, we saw a regression in our rendering here. Again, this is where from 4.0 to 4.1, I should say, not 4.1 to 4.2. And the reason why that matters is 4.0 to 4.1 is when it became the native layout lib. And so obviously some things changed with rendering, and the fun part is whack-a-moling what the rendering changes might have been. This is one of them. Digging in a bit, it turns out that, I'll first tell you how we fixed it. So the way to fix it is, because we aren't yet committing to upstream to the Google repository, we have to do our own bytecode transformation. So the layout lib create bytecode transformation is very boutique, not very extensible. Instead, we decided to use exactly what Makito uses and what RoboElectric uses. And there's this project called ByteBuddy that is, once you figure out how bytecode loading works or class loading works, is quite extensible. I have to give them props. And so what that bug that you saw in the earlier screenshot is matrix multiplication wasn't handled in the delegate pattern when moving over to native layout lib. You would have thought that matrix multiplication is pretty core to rendering. I guess layout lib didn't think so. And so the solution here is to add this concept of a method interceptor, which we created. And so reading through this, we say, okay, for this class, the matrix class, we want to add these method interceptors. And so when there is a native call to multiply let's run this code. And no, I didn't do this myself. I just stole it from RoboElectric Shadows, because it turns out they have the same problem. That's the beauty of working in the same Google code base, is that different teams are solving problems from other teams at Google. Yeah. So with that, with some help, we were able to resolve that. And it turns out this pattern has been helpful. For example, if you use Android X libraries are not part of the Android framework, and therefore they're not going to be layout lib mocked. And so you have to mock them yourself. And so calling resources compat get font, turns out it was following a different code path, where instead of going to the file, I think it was going to, I don't know, something else. And the two methods branched. They had totally different implementations. And so by intercepting, we were able to kind of route it back to the way we wanted it and render it perfectly. Another nice use is if you use view in edit mode. That made sense in layout inspector, but we don't want you to work around layout inspector in Paparazzi. We want to simulate what you have in your emulator. And so we essentially changed the Boolean. We say, yeah, what you want in a layout inspector, you don't want this in Paparazzi, trust us. And so we intercept that. So I talked a lot about view inflation, real spanking new technology. But really, the world wants to know, how does Jetpack Compose support come in? And so Jetpack Compose changes, obviously, how we do views. And that is supported in Android Studio 4.2. The title of the talk was called Paparazzi 1.0, because in Berlin, I was hoping to push a button and say, yay, it's released. But it turns out, just like the 4.1 bump caused a lot of pain, the 4.2 caused a lot of pain. So for now, I'm saying coming soon. And when I mean coming soon, I'm trying to get this in the next couple of weeks. It's really close. What's the problem is that in 4.2, in order to support Compose, after moving everything to the native runtime, they made a decision to not use the native choreographer, but rather do animation via a custom fake. And so trying to understand how animations work in this new world and not how Android actually runs choreographer is a bit frustrating. So things like animations just started breaking. You can follow my branch and hold me accountable. It's funny, some of the hacks that need to occur, but we're almost there, and then we can do some Compose support from there. I am optimistic that once we land 4.2, the only remaining release after that, well, at the moment, is Arctic Fox's layout lib. That's released. Yes, Bumblebee is coming up, but I don't get access to that layout lib until they tag it, and Google sources don't get released until they finally push the product out, so I'm not worried about that yet. In the near future, what I hope to do is, instead of relying on a binary from Google, converting the Bazel scripts to Gradle, building it from source, and maybe then hopefully having some collaboration with the team and working some of the APIs so that there can be multiple consumers of layout lib. Because it is a powerful library, but right now it is meant for internal use in the IDE at Google, and we're just kind of creeping on their repo and making a tool out of it. And that's the talk. Hopefully you learned some stuff today. I am going to be around for any questions if you have any on the side, and follow on Twitter and follow the progress of the library. Thank you.